I'm Kevin Hawkinson. I work at OpsCompass. I play a couple different roles. I'm our director of customer success, talking to a lot of our customers, but I really have a legacy as more of a principal cloud solutions architect. So I do a bunch of those tasks, and I'm going to come here to talk at our chapter meeting. Who's in your cloud? Kind of the objectives, and we probably saw this from the outline, is we're gonna, it's this monitoring, security, and visibility are critical, right? So in this talk, we're going to talk why about cloud is special. We're going to talk about cloud APIs, including some things like the management plane, the control plane, the data plane. We've got this term we're going to be using called cloud state monitoring. We're going to talk about what is it, why is it important, who needs awareness of it, and more specifically, we're going to tell it through the use of some use cases, right? And it's not just an academic definitions; those are up front, but some actually examples of things that are interesting. So during the talk, if you have questions and you want to ask them, every time I hit one of these transition slides, I'm gonna reach out. Carrie is going to be helping me, and then we'll go ahead and I'll kind of do questions at the end of each section if we want, as well as at the end of the presentation too. So when we see one of these colored slides come up, I'll look over, I'll see what kind of the open questions are, and then I will ask Carrie if there is any. So just to keep us on point, but still be able to be a little interactive during the sections. So when I talk about cloud, I really, I'm really thinking about the three main hyperscale cloud providers: AWS, Azure, and the Google Cloud Platform. And when you look at what the value drivers are for those cloud platforms, there's the obvious first two, like cost and scalability, right? But what to me is almost the most interesting is the third one from this Forbes article. The fact that hyperscale cloud providers are interoperable with other systems via their cloud APIs. And that's what really lets them expand their capabilities and accelerate cloud adoption, because you have access to a lot of things that you may not in other competing platforms. It's somewhat hard to find some good definitions of things. So I have the next couple slides, and I'm going to go through them just a little fast, but let you read them. Cloud Security Alliance themselves defines what the management plane is. And they talk about this API interface to managing your cloud assets, right? And that's important. That's what also the consoles use. Google Cloud Platform ends up defining three planes, and I'll be interested from our Google friends on the call if they've got a better source reference of that. But they separate management plane from control plane from data plane, with kind of control plane being in the middle. So they reference these three. Azure defines it into two categories. They talk about control plane, and this is the definitions that I'm most, I won't say comfortable with, but I've heard the most, where your control plane manages your resources, but the data plane is the capabilities exposed by your instance of that resource type. For purposes of some of these examples, this definition is the one I'm going to spend more time on, because it talks about in Azure, all requests for a control plane end up going to a common Azure URL, right? So there's globally a management.azure.com endpoint that those operations go to. But they call out the data plane operations because they're sent to an endpoint that's specific to your instance. They're not necessarily limited to REST APIs or a common endpoint. It might be, your database server, it might be specialized protocols. So data plane operations are different in that they're instance specific, which means the protocols are different. But control plane has a lot of consistency and commonality. The other items related to the kind of the APIs that come out of cloud providers aren't really the inbound APIs, but what I like to kind of call the outbound APIs. And for example, in Azure, any changes to subscriptions or resource groups will go ahead and emit events related to those changes. And they will drop it on something called the Azure Event Grid. And they'll end up creating events for changes. Azure doesn't create events for Git operations, but they do for things that are put, patch, post, delete, things that are sent to that same management endpoint. What data plane operations in Azure don't create events. So things that would go here in this example to your blob storage bucket. So it's kind of like I said, I usually refer to those as the outbound APIs. It is putting stuff in an event on a queue or a grid and you're getting it, but it's something important related to the APIs to monitor. Calling out too that Azure, with their common single control plane, it means they've designed it to be globally. It's across all regions. It's across all zones. It's engineered to be, not dependent on a single data center and not taken down for maintenance. So Microsoft believes they can engineer one control plane endpoint that'll work for everybody. And that's important when we compare it to AWS later. Now, AWS didn't have a good straight up definition of control plane and data plane like GCP or Azure did, but they kind of back into it when they talk about their events, especially the events that kind of go through CloudTrail. They talk about management events and refer to them as control plane operations, and they talk about data events known as data plane operations. So they use the same terms, but they don't come out and kind of define them. At least my Google foo couldn't find a reference in the documentation. So, and then lastly, AWS, as we know, loves their regions, right? And they think that region isolation is key to a lot of their resiliency. So the service endpoints for the control plane of services in AWS are region specific for the most part. Services like IAM does have a global endpoint, but everybody else is regional, right? And during the AWS keynotes in the last couple of weeks, they kind of stated that's why the problems in US East 1 didn't expand beyond the rest of the regions. But it's just kind of a difference in architecture on how the control plane is managed. Right? So from the end of this first section, right, kind of quickly going through a couple of those definitions, I wanted to just highlight from this and recap. There really was no common definition for management plane, control plane, and data plane. There's a lot of similar concepts. Of all of them, data plane was probably the most common across of them. And just pointing out that there's significant differences in both the architecture and infrastructure related to these cloud APIs across the hyperscale cloud providers. I didn't touch on the Google structure there. I had a hard time finding a explicit reference, but everything I could find, some of their kind of Google front door services, they're more of a global, kind of a global deployment model as well. They've got a lot of solid architecture from many years related to handling those requests. So time for the first question break. I'm going to assume that no one had questions about boring definitions because they're not all that interesting. Now we're going to get into this term that we talked about, cloud state monitoring. All right. Of course, every good definition should go to a very credible primary source like Wikipedia. And if I really had my streaming stuff, I would insert the laugh track here because that was funny. But it is an interesting points from the Wikipedia definition that were important just to define state for everybody. Realizing that state is often used for computer programs that operate sequentially on streams of data, right? And the information about the previous data received is stored and used to affect the processing of the current data, right? Oftentimes we hear this called a stateful protocol, right? And that data that's carried over is called the state. So when I'm talking about state, I'm thinking about state in terms of this, in terms of what you might use for a stateful protocol. Therefore, cloud state monitoring would create the cloud resource changes, as a stream of data, right? And intelligently monitor both the current data as well as changes from the previous data or state. And kind of taking that stateful protocol approach, tying into those outbound APIs, those event grids that come out of the cloud providers. We're going to have a bunch of use cases going on, but just some easy examples to think about this. You're monitoring current data for security risk configurations. I left port 22 open, but I monitor changes in data for things like configuration drift. So the state is probably more like the second one on this list because it's looking at the previous and the current state at the same time. Another kind of definition, and this particular definition came from Microsoft, although this four-letter term is another one of those Gartner terms. I don't think it's got its own quadrant yet, and who knows what's going to happen to it. But the term of cloud security posture management comes up, and it's defined at the point that Microsoft defined it then as new functions. It does things that were impossible or difficult or manual before the cloud, before these cloud APIs and these events were universally available to us. And cloud security posture management is an emerging discipline, right? And it's probably going to disrupt the norms of the security organization, right? It's going to have new capabilities. It's going to shift responsibilities among roles. It's going to create roles. This is the hype, right? On like almost everything that comes out with an acronym, there's something really cool and hype about it. But I do believe that the availability of these APIs and the data of these APIs really does give us something that we didn't have kind of pre-cloud. That's kind of why cloud is different. This slide and the next slide are the only two slides where you will see the explicit OpsCompass logo, just because I wanted to use that as kind of a reference because that is the space that I'm in. That's the things that I think about every day. So this diagram here, and you can go ahead and Google OWASP Cyber Defense Matrix, is based on a model that kind of maps the kind of CIS access types along the bottom and the NIST cybersecurity framework security functions along the top. And the idea is you want to be monitoring stuff. You want to have a proactive security posture, and you don't necessarily, want to have a reactive, to security events first. But realizing that both are important for a security program. When you think about identifying, protecting, and detecting, understanding about your state monitoring is about that protect and about that detect, and trying to figure out if the thing that changed was related to a security event, or if the thing that changed was related to just something that you need some normal architectural awareness for. So the first three sections the first three security functions of the NIST cybersecurity framework, the important things to understand from here. So, and on the bottom of this slide, you see that you want to use technology more on the left side, and you want to save your human time and your people to work on the more complicated problems. That's kind of the one slide with some pretty colors, and the other one that I made myself, which is a lot less pretty but still has colors, is just this picture. And again, not meant to be totally read through. This is actually a very simplified view of kind of cloud architectures, but it sets up the reason kind of to talk about the different components of an API structure. You'll see everything on the left that's coming in, whether it's SDKs or APIs or infrastructure as code or the portals, all comes in over APIs to just some different kind of management or control plane services. You'll see that there's policy enforcement points, your AWS IAM, or your config rules retrospectively, or Azure Policy, Azure RBAC, both of which log events, either CloudTrail or Activity Log. They send stuff to CloudWatch events or Event Grid. So if you're going to have a system that does cloud state monitoring, and that's represented by the OpsCompass logo in the corner, you not only need to listen to the events for changes, but you need to reach in to those control plane APIs to be able to get at that kind of that metadata about your cloud resources. So as we go through the next set of slides that have use cases, I'm going to refer back to some of the components in these boxes. This would be a time if you wanted to screenshot this, you could refer back to it when I'm talking, or we can just, you can look at the deck later. So just wanted to point out that's the point of this slide, is to realize how things are wired. All right, is everyone awake still? That's probably the next question. Or should this be said? Who needs caffeine? Okay, we'll move on to the next slide. Figure I would stop. When I think about a best practice kind of cloud operations team, or, if I think about a cloud center of excellence, I've taken this diagram from the Microsoft Cloud Adoption Framework, and I've thrown in some other personas in there. So in their progression from a cloud MVP to a fully cloud kind of optimized, they like this is their ultimate solution, right? You're focusing on self-service, and you have some centralized governance and automation and security, but you have independent teams that can deploy stuff to cloud. So it's a big harmony of everyone working together. Because I threw a couple other kind of sets of personas on there. I threw DevOps teams, even though I know a DevOps is a culture, not a product or a team, right? I still it's still a word that people understand. I threw in architects. I threw in risk and compliance separate from security, just to kind of set the stage for how I view in the organizations that I've been in or have been working with, how things are kind of structured across the team. And I'm assuming a lot of you on the call probably feel aligned with kind of one or maybe a couple of these groups. But when I talk with these groups, and I've just kind of called these personas, I've just kind of abstracted, or genericized what they might say. I've talked to development teams, and they believe in automation, and that's the key to success. But they say, well, doesn't my CI/CD pipeline control all these cloud resource changes? They're all in on this pipeline, and they think that's in control, and we're going to learn why that might not be true coming up. Your architect oftentimes is concerned about the visibility into all the resources and policies. They want to see some consistency. They want to know what's out there. Right? Your cloud security practitioners oftentimes set some standards, and they want to know if you've drifted from those baselines, your security and identity baselines. Not only did we set things up to secure, but is it still that way? Have we drifted from it? What do we need to change? And your risk and compliance teams, they want to be able to intelligently track that compliance, right? When things are constantly changing. Just, the developers want to constantly change it. The compliance teams often, maybe we're used to doing a report every year or every quarter, and now things are constantly changing, and they'd like to be able to access that evidence or that information as it's happening. So you kind of got some kind of key personas that all are interested in kind of the state of the cloud or cloud state monitoring. So when I ask the question, who is making changes, and it's going to be you as the customer, and I use some of the same terminology that's kind of used by the cloud vendors, the workload teams, and those are the ones, either building product or deploying kind of third-party product. You've got your platform teams. Oftentimes they're called your landing zone teams, or sometimes your CCOE's got a team. They're all kind of building your subscriptions and your access control. They're enhancing automation all the time in those landing zone areas. And you've got your security teams, and they're updating policies. They're turning on kind of new and important security controls in the environment. So you've got at least 3 groups of people making changes in your cloud environment. And then you've got cloud providers making changes, right? They might be adding new services, adding new features to existing cloud native services. Maybe some of those features aren't going to enhance security. You also have cloud providers having a lot of hosted open source software. So they're updating the versions of that software. There is continuous change in the environment that maybe didn't come from the CI/CD pipeline, and it's potentially creating risk. Not necessarily, right? But it's something to be aware of. And when I talk about the shared responsibility model, this has kind of been around for a while. Every one of the hyperscale cloud providers has a version of it. CIS also has a version of it. This is what they all look like. And you'll see they all split the difference between, well, almost all of them split the difference between infrastructure as a service and platform as a service. They all have layers on what the cloud provider is responsible for versus what you as the customer is responsible for. But in the end, every single one of them puts data or content or information and that accountability at the top of the stack, which is like the customer is always responsible for. And interestingly, that's oftentimes monitored from the data plane as well as access to it from the control plane. So that's kind of the shared responsibility model. I wanted to just put this eye chart of the multiple versions just to show everybody kind of agrees that there's responsibility to go around, and it isn't just kind of one team. Okay, going to get into one of our first examples here. And it's going to be the Azure storage account. All right. An Azure storage account, or the kind of blob storage in Azure, similar to S3 object storage, one of the first services that was out there. It contains kind of data objects, blobs, files, queues, tables, disks. Pretty common service for cloud providers. The storage resource provider, right? And in Azure, services are known as resource providers inside the Azure control plane. So you'll see the word resource provider, and you can just think that's an Azure service. That's kind of an implementation, right? It lets you manage this account programmatically, right? And every API requires, the request to be versioned. So for an example, I just pasted this nicely formatted version of kind of a REST API into the management plane for a storage account. And we're going to be looking at kind of on the next slide something related to this. But you'll see that it's very nicely formatted, what subscription, what resource group inside the subscription. It's going to highlight that it's the Microsoft storage provider. It's going to give the name of a storage account, and then there's going to be that API version is going to be the last parameter there. Now, don't try and read the code on this slide, right? The point of this is that green colorization that you're going to see, because the highlights actually include specific values for a resource that I created in the Azure console. What I did was I called an older version of the API, the one from November 2018, to kind of simulate if I had created that storage account back then. And then I called the June 2019 version of that API. And you will see that 4 new security features had been added to Azure that I now would have the ability to enable. Whether I wanted to allow public access for my blobs, okay, or disallow it, whether I want to use a specific encryption key type, if I want to turn up the minimum TLS version, and if I want to do some private endpoint connections. The cloud provider made a change here. They added functionality. That functionality you could either read about in the updated documentation, or you could actually, detecting the change in the state of this cloud resource, you could realize that there's some more functionality there that maybe you would want to investigate. Okay, so that type of change is extremely interesting to me because nobody made a change in a pipeline. Nobody went in the console and made a change, but yet a change now exists that is beneficial to your organization's security state. Let's just remind ourselves about TLS, right? There's been a couple of versions, 1.0, 1.1, 1.2, all right? Prior to that change in kind of June, it might have actually been in April of 2019. They only allowed 1.0. The change that Azure made was, hey, we are going to now enable the future versions, but we're going to still allow clients to connect with 1.0 because we don't want to, they're backward compatible. They don't want to break stuff for you, but they want to give you the ability to make a change. So therefore, not only is this property not set by default, but it doesn't even return a value unless you set it. And if the value happens to be set as null, then it actually defaults to the original version of TLS 1.0. And if you do want to set it, it requires an API call into that April 2019 or later version of kind of the API. It's there, it's not turned on by default. You have to explicitly turn it on, which is good because they don't, Azure doesn't want to break you, but you also then can't take advantage of it. So that's kind of just the reason it's important to monitor, because it's like, hey, it might not even have showed up. That's fun. Now, in this slide, I'm going to, again, twist the definition of infrastructure as code to meet my needs, right? Just like I twisted the definition of DevOps. So I think most of you, and Ann, correct me if anyone has got a different question on this, but most of you think about infrastructure as code as those kind of JSON-based templates that you create, that you put in your pipeline. It defines how you want something created. You send it to some sort of deployment engine, and it goes and it creates the resource. So in the example on the left, you'll see the only like 5 fields that you need to define to create a storage account, right? You run it through deployment manager, it creates a thing. Now, when you look on the right, you'll see that not only are those 5 fields valued, but there's a lot of other fields with a lot of other default values that have been turned on. Some of these are items you weren't in control over, like the endpoints, which are based on the name. Some of them do have some default values. So when you compare the left to the right, the question that I ask customers is, should you consider the JSON-based output from your REST APIs also to be infrastructure as code? And it's not something that you want to get and check into source control necessarily like the same way you would do for one of the templates you deploy, but it is something that you could pull out new versions and do that same type of difference that we did 2 slides ago. So in that way, I refer to it that way, even though it's maybe not the most proper definition of it. The other thing I like to point out on this slide is, where's our friend minimum TLS version? It just did not get valued. Again, it was that tech note that we had earlier. If it wasn't explicitly stated, it's not going to be valued. It's going to come back, either be missing, be null. It's going to be TLS 1.0. So there's other things that are kind of hard to catch related to this. This was kind of, like I said, I feel like a very interesting mapping, talking about infrastructure as code versus the source of truth, which is the cloud providers' cloud APIs, and getting the state of that data. Next slide, we're going to talk about Amazon RDS. If you read this slide, you would think that RDS will automatically do upgrades based on this comment, right? If you want to automatically upgrade, turn on AutoMiner version updates. And in this example on the screen, it's turned on. It's true. This should be Boolean simple. But if you look closer at that, you look at the version of MySQL 5.7.28, and you look at that timestamp that's in there, which is the last restorable time, which means that we must be past that time when this JSON was captured. And then you look over to the versions of MySQL that were both generally available and then supported on RDS. And there's always a lag too between the versions that are, when they came out and when they're supported. You will see that 5.7.28 was basically from February, and there had been at least 3 versions of MySQL, 2 supported by RDS since then. If you're like the little floating head icon there in the middle, like me, you're probably confused, wondering, why is this? I have this on, it isn't upgraded. The answer is, you call this API and you get what the current database engine versions are. And it's another cloud API that you need to know about. And I asked about MySQL 5.7.28 in this API call, and I got back a list, and neither of 5.7.30 nor 5.7.31 were auto upgrade eligible. They're set at false. So there are newer versions that you can manually upgrade to that aren't supported by that auto upgrade flag. So when you think about this API call, this is really another kind of state of the cloud or a cloud configuration that you need to monitor to understand the full state of kind of what your RDS version exposure is. So I was confused, so I kept digging into the documentation, and then I found this very fun quote. For some RDS versions, in some regions, one minor version is designated as the automatic upgrade version. Oh, and by the way, RDS doesn't automatically set newer released minor versions as the automatic upgrade version. Okay, so that was a little disappointing to know that they did that. But what was the most disappointing to me was a couple of the key regions in AWS don't have any auto upgrade versions pegged for any release of MySQL. No upgrade support at all. And the regions that do have it don't, none of them support the latest version. And there's differences in the versions that are supported across regions that do support the upgrade. So here is where the AWS strategy of kind of region isolation plays out in kind of an inconsistent experience for a developer, right? Meaning that maybe this field is not the field you want to set. You just, as a team, want to be in charge of your own versions. You still maybe want to monitor what the current versions are so you know what you can manually upgrade, but don't necessarily trust some of the settings that you can. So this is, again, a reason to manage state, right? And when I recap on these previous slides, we're really, you think it's Boolean simple. If an engine version changed and that was on, probably an AWS change, maybe, right? The absence of a change when new versions are available, like the problem we had, something you want to monitor, right? You want to monitor that set of available versions and the region consistency problem. That just kind of simple example has got like 5 different, I feel, pieces of information that are important just to understand the whole picture. Azure RBAC. This again, I'm not going to read through this whole picture. The thing I love about Azure, right, is look how consistent and well defined that is. You got these security principles on top. You have role definitions. You have scopes where you can apply that role. And then you have this role assignment. So the grant access by assigning security principle, a role, and a scope, very well defined, as well as the assignment kind of flow down a hierarchy. If you don't have the action, you don't get it. If it, things are blocked, it's like very nice and very structured, right? I really like their security model, but we'll see a caveat coming up soon. What's interesting then about the way that Azure does things is they have got this concept known as an extension resource. So an extension resource is a resource. As you can see here, there's JSON representations of it. There's an API to get it. But it's a resource that's applied to another resource type to extend that capabilities. So by monitoring the resource you don't get it, you actually have to monitor the extension resources tied to that as well. Now, if you come from an AWS kind of space, think about resource-based policies because they're often attached to a resource. Think of that as similar to extension resources. And if you think about an AWS custom role, that would be really similar to your own role definition in Azure RBAC. Today, also these role definitions, they tie to the subscription. They just kind of like an IAM role kind of ties to your account. So just kind of think of that model. It's another piece of resource that's in place. When things get interesting is the consistency hope that I had earlier. Yeah, I forgot about things like legacy, where some of your classic subscriptions had these other 2 special roles that don't show up as an Azure role. They're a special Azure AD role, right? And then there's this little enablement thing where you can elevate your access. And I've kind of put it in the red box on the screen where you can go ahead and as a global admin in the Azure Active Directory, you can give yourself full access to your entire Azure subscription. And it's not one of the roles that's attached to one of your resources. It's not the role attached to your root management group. It's a special switch. And I equate that to that break glass AWS root account that you might have. You don't really want to use it, but when you need it, you really need it because things are serious. So it's something you need to monitor. If somebody uses this, you want to monitor it because they have now given themselves elevated access. And it's not a state that you want to consistently be in. You want to turn it off when you're done. Fun things to monitor. The Other item that was on the slide of things to monitor, there's something called Azure Policy. And then here's some of the Microsoft language. It helps you enforce things at scale. What's interesting about it is it compares the properties of the resource that's being created from that cloud API against some business rules you have. And it's different than RBAC is that it's not worried about the operations that are happening, but it's worried about the properties of the resource. And the combination of policy and RBAC are the things that give you your kind of full scope of control in Azure. A kind of a specific example that I use about it. First, I remind people about resource tags. And resource tags we'll use in an upcoming use case as well. They're labels. You have this user-defined keys and values. You attach them to cloud resources as metadata. They help you organize things. You can use them for IT-aligned operations like, what's your environment or what's the workload. You can use them for business-aligned requirements like accounting or cost, allocation, ownership, criticality. And with the caveat that there's some services that select tags. They don't support tag and create, right? There's other limitations. Tags are an important management technique in the cloud providers and something that's easily enabled by the cloud APIs. So an example of an Azure policy that has the effect that you might not want it to is these tag policies below. And if you remember, you process requests to create or update resources before they're handed to the appropriate resource provider. So there's this interceptor layer where it can change or block the API based on the rules, business rules in Azure Policy. Here's an example of enforcing tagging rules by applying the needed tags before deployment. But if you look at a couple of these examples, and if you thought, hey, I'm this DevOps team, I've set some things in my infrastructure as code, it's possible now for one of those cloud operations teams to go ahead and modify that request. Maybe they're adding tags, replacing tags. Maybe they came up with a brand new required tag and now are denying your request because it doesn't have the tag or the tag and a specific set of values. A pipeline that was working fine could now just break, or it could output something different than it thought. And in some technologies like Terraform, tags are part of the state, and you'll end up, if tags are changed on you when you read the current state and try and sync it up, it might be different. So these are kind of a policy can intercept and make changes on you, and it's something you gotta make sure that you're kind of monitoring the policies that go in place. That it's affecting your resources. Coming through the last use case until we're done. Last example, talking about AWS IAM. Okay, and they refer to their stuff as policy 2, which is a totally different policy. Here's an eye chart we're not going to read. Just realizing that the complexity of the evaluation logic from AWS goes through a number of steps that are a bunch of different policies, whether they're coming from the organization, the resource, some permission boundaries, session policies, identity policies. There's multiple places that you can take the same policy language and apply it into AWS. All need to be monitored. All can affect what happens as far as the decision. Just like Azure has got built-in roles, AWS has got managed policies, right? Standalone policies administered by AWS, which means that it's got its own identifier, its own Amazon resource name, and that includes the policy name on it. And it's got an identifier there that's kind of unique, and you can figure it out. And you can't, it's managed, right? Because it's managed, you can't change the permissions defined in it. But AWS occasionally updates these permissions in a managed policy. That's kind of, again, a change that is being made not by you, but by the cloud provider. And interesting, these policies, if you dig into them, even though they are quote unquote least privilege on the actions that they allowed, usually they're resource star. So they're not least privileged on the resources they apply to. So that's kind of just for those of us that have dug into AWS IAM, something that's interesting to learn. Now here's another feature that we do have natively in OpsCompass, but what I'm showing here on this screen is kind of one of my favorite open source projects related to the same problem. There is a person that is running this every kind of 4 hours, although they did up it to every hour during reInvent because there are so many announcements, therefore so many new managed policy changes. They grab all the managed policies, they see if there's any changes, they basically check them into GitHub, and you can see the differences. And you can either get alerted straight from the GitHub repository, or you can follow this account on Twitter, and you can actually see all the changes that come in. And this is interesting because there's changes that happen and then they're undone, or that they change quickly. And it kind of makes you wonder what kind of control is on these changes. A specific one that I like to pull up is this security audit one. And I do this because this is one you often grant to your cloud security posture management providers. You don't have the ability to set the version, but when this change happened in September, these are the new set of permissions that you have just granted. Now, it is managed by AWS. It probably does make sense, but again, it's a change that you didn't make. You didn't maybe review the audit. It happened, and now if you've granted that to an external person, like a vendor, that's the new permissions they get. So again, important to monitor. Coming to the end here, the last kind of subsection with AWS IAM is when you look at how they define their access levels, they've got listing, reading, writing of permissions. Those are kind of a little less interesting for this example, so I've graded them out. But they like to highlight two things. They like to highlight permissions management, the ability to grant or modify resource permissions, with a special tip in the documentation that you should monitor this. It's super important to monitor. And then they talk about tagging. And it's just only changed the state of resource tags, only that. And we saw earlier that tags are used for a lot of things, including cost reporting and ownership and a lot of metadata things. So it kind of makes sense on this surface that tagging is kind of its own special thing. When you dive into what AWS has enabled for attribute-based access control, that's an authorization strategy that uses the attribute permissions or the tag permissions in AWS to grant you access. So they will have you match a principals tag to a resource tag, similar to that code that's on the screen now, as a way to kind of make it easier to grant access to resources in bulk. If you're tagged with a certain project ID and the resource is tagged with a certain project ID and this policy is in place, you get access to all those resources. So it's a nice way to kind of scale up that permissions. You're not listing out explicit resources. You're not trying to do prefix-based condition matching. You're doing tag-based matching. Kind of an interesting way to do some things. But again, you need to monitor it. And if you look at our previous access levels, we have now elevated tagging to the same level as permissions management. So if you in your organization thought, well, tagging isn't as important, I can have other people do it, and then you have some developers turn on attribute-based access control, realizing now that you have a kind of a change in state where you've got now certain policies with conditions that include those tag attributes that you want to monitor. So again, monitor, there's CloudWatch events that are created. You can create event rules on them. And then you can either do automatic workflows using Lambda functions, human workflows as part of auditing, any number of types of things you can do. So, but again, it's important. Again, it's everything is interrelated. So the state of everything together becomes important to monitor. Closing thought slide, cloud APIs, one of the most powerful value drivers. Resources can be changed by any number of actors. Monitor the state of these resources for both security and other misconfigurations. And then kind of the key point, a change in state of that cloud resource can provide you information related to your security posture. So, all right, thank you, everybody. That is my contact information. That's my LinkedIn.